Good evening, Professor. My name is Azzuddin Nasser. I am a student in the German University in Madaba. I study industrial engineering, and today I'm going to talk about light transmitting concrete. So, the introduction: light transmitting concrete, also known as translucent concrete, is a special type of the popular building material concrete, which has light transmissive property. This light transmissive property is due to uniform distribution of high numerical aperture plastic optical fibers throughout the concrete's body, and it's also known to be transparent concrete. The translucent concrete was first developed in 2001 by a Hungarian architect named by Aaron Losonce. What is an optical fiber? It's a flexible, transparent fiber made up of glass or plastic and as thin as a human hair. An optic fiber transmits light between two ends of the fiber by the process of an internal reflection, and it transmits light so effectively that there is almost no loss of light conducted through it. And we have a picture here to show the three sections of an optical fiber. The first one is the core, the second is cladding, and third one is coating. Also, it can be named by the buffer. Concept of internal reflection. The translucent concrete works based on nano-optics, where fibers are placed directly on top of each other, so fibers act like slits and carry light through in what's called the principle of total internal reflection. Fibers pass more light when tiny slits are placed on top of each other in the following manner. We have pictures to show the way how the lights move inside the fiber. The concept of internal reflection: when a ray of light travels from a denser to a rarer medium, so that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomenon is called total internal reflection. In the optical fiber, the rays undergo repeated total number of reflections until it emerges out of the other end of the fiber. Even if it's bent, it doesn't matter. So here we have materials used in making concrete. We have four basic materials. The first one is cement. We can use OPC or any ordinary Portland cement. Second is the sand, fine aggregate through 1.18 millimeters safe. Third, we have water. It's recommended to use drinking water quality. Water tap is not good. Fourth is optical fibers. Thickness varies from 0.5 to 2 millimeters. Manufacturing process. Okay. So the manufacturing process of transparent concrete is almost the same as regular concrete, where small layers of the concrete are poured into the mold and fibers are dipped in it. Nowadays, semi-automatic production processes use woven fabric instead of single filaments. Fabric and concrete are alternately inserted into molds at intervals of approximately 2 millimeters to maximum 5 millimeters. Or there's another method where many holes are punched on side walls of the mold. So optical fibers have to be run through these holes from one end to another, then concrete is poured in it. Technical specifications. Okay, we have some technical specification. First is the form. It has to be prefabricated ingredients. 96% is concrete, the other 4% is optical fiber. Density 2100 to 2400 kilograms per square meter. Block size, we have 600 and 300 millimeters. Thickness, the thickness is ranged from between 25 to 500 millimeters. Color should be white, gray, or black. Fiber distribution, organic. Finishing, polished. Compressive strength from 25 to 220 MPa. Usually it's 50 MPa. Bending tensile strength, flexural strength 7.7 MPa. Material performance. Concrete retains its strength. High density top layer concrete infused with optical fibers. Frost and de-icing, salt resistance, fire protection, and highest UV resistance. Environment impact. When a solid wall has the ability to transmit light, it means that one can use fewer lights during the daylight hours. Okay, so here we have the pros and cons. Starting with the pros, less energy consumption, illuminated pavements, homogeneous in structure, finishing surface, routine maintenance not required. The cons are it's very expensive, it's a factory product, and labor with technical skills are in need to use it. Applications. Yeah, its applications first in furniture for the decorative and aesthetic purposes. Also, it can be used in partitions walls. Also, it can be used where sunlight does not reach properly. Translucent concrete blocks suitable for floors, pavements, and load-bearing walls. For increasing visibility in dark subway stations. 5. Translucent concrete works on restaurants, clubs, and other establishments to reveal how many partitions are inside. Sorry. Ceilings of any large office buildings or commercial structure. Incorporating translucent concrete would reduce lighting costs during daylight hours. Where do we find it in real life? Okay, so the use of lightweight concretes has been widely spread across countries such as the USA, United Kingdom, Sweden, Denmark, Iceland, Australia, and Kazakhstan. The conclusion: the light transmitting concrete do not lose its strength parameter when compared to regular concrete. It It has good light transmitting property, and the ratio of optical fiber volume to concrete is proportion to transmission. It has very vital property for the aesthetic point of view. That's the end. Thank you very much for listening. Hope you enjoyed it. Bye.